Hey, and welcome back to another video of me learning lightweight Java game library. So in the past week, I have been delving into collision detection, and it has not been entirely straightforward. Reading around, I learned that usually you have two phases, so the broad phase and the narrow phase. And the purpose of the broad phase is not to do the actual collision detection, but rather to tell if two objects are close enough that they might be colliding, and they should have the real collision detection algorithm run on them. So that is what you are currently seeing. These are axis-aligned bounding boxes. So these boxes are a bit larger than the entities, and they are only supposed to tell if they are close enough that we should be running the narrow phase on these two entities. So currently when you're seeing this, I only have the broad phase here. So this is what we're seeing. Our axis-aligned bounding boxes are actually colliding, so yay. This means that later, when we have implemented the narrow phase, we can test these against each other. Woohoo! Alright, here you can see the shapes that we are using for the narrow phase collision detection. And as you can see here, our trees have auto-generated collision meshes, which I generated inside of Blender. But our player model currently has this sort of low poly cylindrical shape. We probably want a capsule collider or something like that, but I haven't implemented that yet. But as you can see, the collision detection is working, so yay. And also the axis-aligned bounding boxes are still there, I'm just not drawing them. So I went for the LWJGL algorithm, which works by finding support points on the Minkowski difference of two colliders, and if the world origin is inside of these support points, then we have a collision. If that doesn't say a lot to you, then don't worry, it didn't to me either, but there are some great resources, and I will put some links to them in the description below. All I can say is thank you, Winterdev. So the LWJGL algorithm is unfortunately not enough to be able to solve physics collisions, and the reason is it only tells us if we have collided, not where we collided or how far into each other the colliding objects were. But I was getting quite tired of trying to find good resources, so I took a break from the whole collision stuff. We can at least detect if there's been a collision, and instead I implemented this little, very simple AI. It just runs away if you get close, and it's constantly doing the single ladies dance. And as you can see, it also triggers the collision detection and all of that. So it was really just to be able to see what it would look like inside of the game if there was another player. So now quite a few new things have happened. So most obvious is her new outfit, of course, the little dress, the hat, and the shoes, but also in the animation system. Now the animations are blending. So before they would, for this spell animation, it would just cut straight from her spellcasting stance to back to the idle animation, but now it's blending. So that's very nice. Another thing, if we zoom in and out a bit, is that you can see that the fog isn't changing anything. And that's because instead of basing the amount of fog on the distance from the camera, I now base it instead on the distance to the player, which I think gives a more interesting effect. Another thing that I talked about in the last video was that I was not sure how to implement the facial system with Morph Targets. And the reason was I wanted to upload all of the available Morph Targets to the graphics card in the same way that I do the normal vertex positions. But I could not do that in an array that was general enough that I could just pick from it from the right Morph Target. So I ended up doing it on the CPU. I have a component in my Java code, and I do all of the vertex calculations, and then I upload them to the graphics card. I update the vertex positions for every instance of the model with whatever morph target they currently have in their facial system. So I traded a bit of performance for some flexibility, so the system is now very flexible. You can tell the system to morph into any target name that you would like. If the model has that morph target in its list, it will apply it with the amount that you specified. If not, it's going to do nothing. So that's it for this week's video. I hope in the next week that maybe I'll get into some collision responses so that I can actually be blocked by stuff. But for now, I'm going to leave you with this.